Good evening, everyone. This is Rahul. My video presentation topic is transistor hybrid model. First know introduction. Every linear circuit having input and output terminals can be analyzed by four parameters. One measured in mho, one measured in ohm dimensionless called hybrid or H parameters. Hybrid means mixed. Since these parameters have mixed dimensions, they are called hybrid parameters. Hybrid parameters. First, we know two-port network. The circuit has input voltage current labeled as V1 and I1. The circuit has output voltage and current labeled V2, I2. V1, I1 input current, input voltage, and V2 in our output voltage, I2 input current. These parameters are called H parameters. The H parameters are very popular and widely used because they give accurate result and can be measured easily. There are two ports, input and output ports. That's why it is called as two-port network. For each port, these are two variables, current and voltage. I1 input current, V1 input voltage, I2 output current, V2 output voltage. This is transistor two-port network. For two-port network, the four variables are related in terms of H parameters as V1 input voltage is equals to H11 I1 plus H12 V2. I2 output current is equals to H21 I1 plus H22 V2. The H parameters H11, H12, H21 and H22 are called as hybrid parameters or H parameters. First, H parameters. First one is H11 is the ratio of H11 is the ratio of input voltage and current. It is called input impedance with output short circuited. H11 is equals to V1 I1 at V2 is equals to 0. H21 is the ratio of output and input current. It is called forward current gain with forward current gain with output short circuit. H21 is equals to I2 I1 at V2 is equals to 0. H12, third one, is the ratio of input and output voltage. It is called reverse voltage gain with input open circuited. H12 is equals to V1 V2 at I1 is equals to 0. H22 is the ratio of output current and output voltage is called output admittance with input open circuit. H22 is equals to I2 V2 at I1 is equals to 0. Therefore, the H parameter equation can be written as V1 H1 I1. V1 is equals to H1 I1 plus HR V2. I2 is equals to H1 I1 plus H0 V2. When these hybrid parameters are implemented in transistor, we know that a transistor is a three-terminal device. If one terminal is made common to input and output, then the transistor can be represented as two-port network. The H parameter representation of a transistor depending upon the type of configuration CE, CB, CC. CE common emitter, CB common base, or CC common collector. Therefore, each H parameter is assigned in second subscript letter. E, B, or C depending upon the type of configuration. H parameters representation for three types of configurations. H parameters H11, H12, H21 and H22. Notations in CE, CB and CC as shown in this table. Hybrid equivalent of a transistor in CE, CB, CC mode. The H parameter equation in CE mode can be written as VBE is equals to HIE IB plus HRE VCE. IC is equals to HFC IB plus HOE VCE. In CE mode, common emitter mode, the lowercase suffix indicates small signal value and the last suffix indicates the mode. So HIE is input impedance. In common emitter, HFE is the forward current of transistor ratio in common base mode. The H parameter equations in CB mode can be written as VBE HIE IE plus VRB VCB. IC is equals to HFB current. IC current is equals to HFB IE plus HOB VCB. The H parameter equations in CB mode can be written as VCB is equals to HIE IB plus HRC VCE. IE is equals to HFC IB plus HOC VCE. This diagram represents hybrid equivalents of transistor in CE, CB, CC mode as shown in this figure. These are called CE, CB, CC circuit diagrams. These three are called as two-port networks in transistor: CE mode, CC mode, and CE mode. Coming to the advantages of hybrid model: simple to analyze transistor circuit. Parameters can be easily measured. Applicable to any transistor configuration. Provides better accuracy for small signal analysis. These are four advantages of hybrid models. Applications: used in amplifier design, helps calculate input output impedance and gain. Useful for frequency response and small signal analysis. These three are applications to transistor hybrid models. Thank you.